we are going to try and clear up a few misunderstandings about dot plots so we can be successful. So the first confusion I see is people are not understanding what greatest and most common mean. So when we're talking greatest, we're talking the biggest number. So on this one, this is children in a family. So the greatest number is 6. Most common, we're looking for the highest that goes up. That is 1. The most common is to have one child in a family. The greatest is 6. So when we're talking greatest or most or least, we're going over. When we're talking common, we're going up and down and making groups of them, right? This is the most common in the group. When you have things in common, they're together, right? These are dots are the most that are together. So least common would be 5. Just the smallest amount would be 0. So biggest and smallest goes over, common goes up and down. The second thing I'm seeing that we're confused about is we're not understanding what the numbers and what the dots represent. Every time we work with a dot plot, even if it doesn't ask us to, we need to stop and think, what do the numbers represent? What do the dots represent? So the numbers are the choices they have. The dots are the people or the things that they observed or asked the question to. So let's do some practice here. So here we have the number of children in a family. Sometimes it's easier to start with what do these numbers mean? So these numbers 0 to 6, they're representing how many children are in the family. How many children are in this family? They could have 0, 1, 2, 3, 4, 5, or 6. So every dot, that's a family that they asked the question to or that they observed. How many people are in your family? How many people are in your family? Your family, your family. So the dots are the families. The numbers are how many children are in the family. So understanding that as we're answering questions is going to be helpful. So on this one, we have paint orders. So we can see people ordered 1 to 10 gallons. So these numbers are the gallons that people ordered. So every dot is an order that was placed. That's the people. This person went in and ordered 1 gallon. This person ordered 1 gallon, 1, 1, 1. This person over here came in and ordered 5 gallons. This person ordered 7 gallons. So every dot is an order. And then the numbers are the gallons that they purchased. So this one is a little different. It doesn't have numbers, but it's the same idea. So these words, we have favorite snacks. So the words are their choices. These are the snacks that they could choose from. And the dots are the people that came and chose that snack. So a dot is a person. So lots of times dots are people or things. How many of them do you have? And the bottom is the choices that they can choose from. They're number options. So let's try out this problem here. So you should have this worksheet here. So we have a football coach makes a dot plot to show how many wins his school's team had during the regular season in past years. So this whole thing is about wins. So we can see these numbers stand for the wins. So out to the side, we want to write that the numbers are the wins. So the dot is a season. So in this season, this dot, they won 6 games. In this season, they won 6 games. If I come to a different season, in this season, they won 8 games. So every time we're talking about a season, like a year of football, that's a dot. Every dot is a different year that they played. And the numbers are how many times they won that year. So our first question says, during how many seasons? So if we're talking seasons, we're looking at dots. Did the team have 6 wins? So we want to go to the wins. They had 6 wins. How many seasons, right? How many dots did they have? 6 wins. And we're going to put our answer here. Which number of wins occurred most often? So, right, most often, it was the most common. We're looking for the one that goes up the tallest, and we're putting the number that's matching it. So we go up. This one has the most wins. So 9 was the most common. It goes up the highest. That's the biggest group here. During how many seasons, so we're looking at dots, did the team have at least 8 wins? So we're looking at 8 or more. So we want to count up all the dots for the seasons that have 8 or more. So 8, every time they won 8, 9, or 10, we're counting up all those dots and we're going to put our answer here. All right, in what percentage, every time I hear percent, we want to start with 100. It's 100%. Of the years, did the team have 7 wins? So first of all, we need to know how many seasons are we even looking at. So we need to know what would 100% of their seasons be. So we're going to count those up here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 seasons that we're looking at. And we want to know what percentage did they have exactly 7 wins. So 1, 2, 3, 4, 7 seasons, or sorry, 4 seasons have 7 wins. So we have 4 out of 15. We want to know what percent that is. So I know it's less than half the time did they win exactly 7 games in the season. So if we know how to get from 15 to 100, we can do that, or we can crisscross multiply. So here's 400, and we're going to divide that by 15. So here's 15 can't go into 4, but it goes into 40, 15, 30, 45 is too big, so it goes in there 2 times, is 30. So we have 10 left over, bring down our 0. So we're going to make a list of 15. So we have 15, 30, 45, 60, 75, 90. So it goes in there 1, 2, 3, 4, 5, 6 times. 26 times 15 is 90. We're going to bring down, we have 10 left over, so we're going to add the 0. Oh, now we have 100 again. We just did this. 15 goes into 100, put our decimal there 6 times, and that's going to just keep on repeating. So they won 7 times, 26.6% of the time. So we need to remember, if it's asking which one happened most often or most common, we go up. Which one went up highest? And then so we just really have to understand, what are the numbers? What did the dots represent? All right, let's try another one here. The margin by which Madison wins her sprint races are shown below. So she won by that, like each points of a second every time. So first we want to make our dot plot. So we're just going to go ahead and do that. So we have a 5, a 3, a 4. I'm going to mark that I'm doing 2, 2, and a 1. So double 2 and a 1. 5, 8, 5, 5, 8, 5, 4, 5, 6, 4, 5, 6. We have 9, 2, 3, 5, 4, 3. Lots of 5s. 4, 3, and then 1, 6. 1 and a 6. So before we answer questions, we want to know what are the numbers, so we can see, oh, the numbers are seconds. It's usually going to give us a label right below the numbers. So every time it's asking about seconds, we want to be going left and right using the numbers. And then dots are each race that she won. So, right, every race has a dot. So all of her races, right, here's all of her races, and they're measured in seconds. So what percent? So automatically we know we are setting up our problem to equal 100%. So what percent of the time margins are at least 6.6 seconds? So at least 6 or more. So we're going to count all the dots that are 6 or more. So I see 1, 2, 3, 4 of them. That's how many we have, but how many races was she in total? Let's count those all up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, wow, that's a nice number. Okay, so we have 4 out of 20 times she beat her opponent by more than half of a second, 6.6 seconds or more. So we want to know what percent that is. Now I know how to get from 20 to 100. We times by 5. So I just have to take 4 times 5 is 20. So 20% of the time, she's beating her opponents by more than half of a second. And the next question says, what's the most common, right? Common goes up. What's the most common? Which one goes up the highest? Up the highest, and put your answer here. So we're putting our seconds, right? Which one of these numbers goes up the highest? And our last question says, by which margin shown on the number line did Madison never win? So looking at just at the list, it'd be pretty hard to tell, like, ooh, which ones don't we have? But looking at our list, we can see there's never a 0.7 and there's never a 1 full second. So she never beat anybody by 7/10 of a second or 1 second. So every time we're doing these dot plots, we just want to stop and think, am I using the numbers that go over bigger and smaller, greater and smaller, or am I doing most common going up and down? If we're working with a percent, our number's always out of 100. How many did we have out of the whole thing to get to our final answer?